Okay, let's factor everything first. Okay, everything starts with an x. So the first one has to have a negative times a negative to get a positive on the end and yet have a negative term. We're looking for two numbers whose product is 28 and that add up to 11. 7 times 4 is 28. 7 plus 4 is 11. Down below it has to be a positive times a negative to get a negative on the end. And so we're looking for two numbers whose product is 24 and whose difference is 5. So that's 8 times 3. The bigger number goes with the positive sign because the middle term is positive here. Now everything's factored and we'll need a line for each of these factors. X minus 7, x minus 4, x plus 8, and x minus 3. And then the quotient of all of these. Also note that these two are in the denominator. Those are from the denominator. Okay, so we have here at negative 8, this guy's 0 at negative 8, and the next one is at 3. Let's call this one 3. And after that one, we've got one at 4 and another one at 7. Those are all the places, factors in this quotient equals 0. Okay, there's this one already here. Let's do it. X minus 7 is 0 when x equals 7. And if x is bigger than 7, it's positive. X is less than 7, it's negative. X minus 4 is equal to 0 when x equals 4. And if x is bigger than 4, it's positive. And if x is less than 4, it's negative. And now, x plus 8 is 0 when x equals 8. And if x is bigger than 8, then x plus 8 is positive. Negative 8, I mean. If x is less than negative 8, then x plus 8 is negative. X plus 3 equals 0 when x equals 3, and it's positive if x is bigger than 3 and negative if x is less than 3. So now to finish off our chart, it's like you're multiplying going down, so negative, 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 negative makes a positive. A 0 in the denominator is undefined. It's undefined there, our quotient. But a neg, neg, pos, neg makes for a negative. And a 0 in the denominator is another place where our quotient is undefined. Then we have a neg, neg, pos, pos is positive. And a 0 in the numerator makes the whole quotient 0. A negative, pos, pos, pos is a negative. 0 in the numerator makes the whole quotient 0. And all positives make for a positive quotient. That last line tells us everything about this rational expression. We're looking for where is it negative or 0. Where are the negatives and the zeros? Let's graph where the negatives and the zeros are on a number line here. Let's this be negative 8. This is 3, 4, and 7. So make a little circle around each of these points on the number line. And let's graph where are the the negatives first of all. The negatives live between negative 8 and 3. Let's graph everything between negative 8 and 3. That's part of our solution set. And also between 4 and 7 is part of our solution set. Now where are the zeros? It's equal to 0 at 4. So we'll fill in this end point. It's also equal to 0 at 7, so we'll also fill in this end point. It's not 0 at these points. That's where it's undefined. Okay, so this is the graph of the solution set. And then since there's a negative infinity is at the end of the line to the left and a positive infinity is at the end of the line to the right. We don't really need that in this case. Let's just put the interval notation for the solution set. That's negative 8 up to 3. union with the interval from 4 to 7. Notice we're including the endpoints on that interval. In set builder notation, this is the set of all x such that x is between -8 and 3, -8 and 3, or x is between 4 and 7. This is including the endpoints, and that other one isn't. So here we have three different ways of expressing the solution set to this rational inequality.